So, we will be discussing on basic system errors and see what happens in the case of biometrics. As you have mentioned, there are few components. One component is matcher. Of course, there exists the other component is the image acquisition, pre-processing, feature extraction and other issues are there. But here this error is dependent on many factors, but matcher is the primary component which will help you to take the decision. So, given the two biometrics characteristics of same person or maybe two different persons, the matcher will tell you that whether it is matched or not, right. That means what? That matcher will give you some information about the similarity or dissimilarity. Now, as you know that we will be using the features from the biometrics characteristics, right. So, this while you do the some matching operations, it will give you some score, right. That score, based on that score, you have to tell it is matched or not. What it means? That there is a need of defining some threshold, that if it is above some threshold in the case of similarity match or below some threshold in the case of dissimilarity match, you will tell that the two biometric characteristics are from the same persons, right. That means, you will be telling that these two are matched. So, the word you will find the similarity and the dissimilarity. Say for example, I have the fingerprint. In the fingerprint, we have used the terminology minutia points, and minutia points is nothing but that these ridges are there. There are end points or bifurcation points. Now, given two minutia points, what is given to biometric characteristics of fingerprints? If I tell you that you matched or not, what you do? You will be extracting the features. Now, this features is the ridge end points or bifurcation points. Now, this end point is represented by x, y coordinate and also the angle, right. Because angle with respect to this line, and then you will find out that what angle it is creating. And also in the case of bifurcation, you can think that this is one point and then bifurcation looks like this, right. So, this there basically you will be getting these points, and also that at this point what is the angle, right. So, there are four parameters. One is the type of the minutia point, one is the x coordinate, another one is y coordinate, another one is the angle, right. Now, based on this, given the two fingerprints, you will be finding how many of the minutia points are matched, and if the number is more, then you tell it is they are similar, right, or they are matched. So, out of say 80 minutia points, suppose you got the 60 minutia points matched between the two biometric characteristics, then you will be telling, obviously you will be telling that they are matched. But if it is 50, are you going to tell? That is not known to you. So, based on your training data, you will be taking the decision, and this is an example of similarity match, right. Now, this similarity or dissimilarity measures are dependent on many parameters. One is that data acquisition system, that what type of system you are using, how robust the system it is, right. All those things you have to take into account. For example, that I have a fingerprint scanner which works under controlled environment. Will it work if the temperature is more than 50 degrees centigrades, or will it work if the temperature is minus 5 degree and so on, right. Or that is it okay that every system has certain life period, right. So, I have a fingerprint scanner which I have purchased 10 years back. Will it work for next 15 years, right. So, the device plays an important role, and then the scanner quality is getting changed. So, today in the market I have 10 megapixel camera, but few years back I had only 2 megapixel based camera, right. So, data acquisition system plays an important role. Then the precision of the representations. See, I have the fingerprint, this is 1 inch by 1 inch say, and there are 100 points in it. So, obviously, these points will be very closely placed, right. The coordinate points are very nearby area. Now, I have another fingerprint, they are also having 100 points. Now, suppose I consider only the integer value, x and y are the integer coordinates, then you will find all of them are matching or most of them are matching, right. So, you have to think about the after decimal points also you have to consider, but that representation you have to check. What should be the precision? How many digits after decimal points you have to consider? That depends on the biometric characteristics you are considering, right. So, precision of representation of biometric sample is important parameters. How many minutia points you are looking for? This is also an important parameter. Suppose I have a biometric characteristics you are defining, and it gives you only 4 or 5 minutia points. Is it sufficient to draw a conclusion whether 2 of them are matched or not? So, this is the second parameter. Third one is that degree of uniqueness, right. Whatever you are taking features you are saying, are they unique? How long this properties will be maintained, that has to be studied carefully. So, degree of uniqueness is also important parameters. So, the similarity and dissimilarity are mainly dependent on these parameters. So, you have to be little careful while designing your matching algorithms. See, I have a face image which has been obtained from a camera using a camera of having the resolution of 2 megapixel, and I have another camera now which has the resolution of say 12 megapixels. Now, if I take 12 megapixel based, use the 12 megapixel based camera, and the size will be very large, right. Now, what are you going to do? Obviously, you have to make in the same format, same size, right. Suppose I make it 100 cross to 150 pixels image size, then there is a possibility you will be losing certain features from the face, because resizing, how are you going to resize? That one way is that suppose I have one image and another image like this. So, one way you will be doing that, you will be making, because you want to compare these two images. So, this size has to be same, right, otherwise it will be difficult for you to compare. One way is that you increase this one or zoom this image to a larger area. Now, as you have seen in your midterm exam paper, that zooming is not that easy, right, even though it looks very simple. Have you done that? How is it? How did you do it?
I have done it adding 1 pixel.
3 times. So, what it gives you? That have you done, you write a simple program and add it 3 times. You will find there will be a square effect is coming. Square effect means this was the image and you have zoomed like this. So, you will find that this pixel you have repeated, same effect will be there. Then this pixel you have repeated, then you will find that there is a shade is coming, some shade will be coming, square, 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 shade will come. This is a good practice, right. Simple way is that you take the 2 pixel and make it average of it, it is better. But what I told, no, if you average it, then you get the 2 times. But what we wanted, no, not 2 times, I want 3 times. That is the only problem I gave, right. So, basically the problem you should have written, suppose this pixel value is A, this pixel value is B, and you want to insert these 2 points, right. That is the problem I told you. And you know this is 1/3 and this is 2/3. Am I right? Distance from here is 1/3 and this is for 2/3. So, the value of this should have been 2/3 of A plus 1/3 of B, and this should have been 1/3 of A plus 2/3 of B. That is the better estimate, because I am giving more weightage here, because this point is nearer to A. This point is nearer to B, so I am giving the more weightage on B. Am I right? That is a simple linear interpolation technique. Yes or no? So, the zooming, even though it looks very simple, that repeat it, and you should be very careful while answering the, by seeing the question paper you understood the paper is lengthy. Am I right or not? And once you are lengthy, there are some questions which are very simple in nature. This is very simple in nature. Then another one is that even though I change the orientation, that it is a orientation free, something I gave, invariant, right, del square. You have to see that x, that corresponding change, and also you take the second derivative, they are same. That is the thing you have to show. That is also very half page or 1 page, half page write up. You could have solved straight away. There are 3-4 problems, straight away you earn the marks. And there are some problems where you have to do little arithmetic, simple arithmetic, they are lengthy. Anyway, now I have one image of 2 pixel size, 2 megapixel, another image based on the 12 megapixels. Now, if you have to compare it, you have to what you have to do, one has to make of other size. So, zooming is one way, but by putting the zooming, you may introduce some additional features. So, for example, in the case of fingerprint, if I zoom it, then there is a possibility that some bifurcation or some additional endpoints will come. See what happens once you give the fingerprint, the regions are like this, right. Once you give the fingerprints, so there is a possibility because of some noise, there are some cut is there, right. Now, if you enlarge it, then this cut also will be enlarged, or right. So, you need to have, because obviously, if I see minutely, this cannot be a cut. This is because of noise only you got that blank area. So, you have to fill that and make it a line, but by introducing the drawing a line, right, I could have done this one, I will increase, because I will assume that this is a line if the number of pixel where it is becoming 0 or it is not a line. So, I will add no, it is a because of error. So, I will add that one. But by introducing that line, again there is a possibility you are making an error, because in practice actually there is a line, because one line, one pixel that may be there, because you cannot ask the concerned subject, yes, you come and show your fingerprint, based on that I will link or not, I will not link. That is not possible. So, if you zoom this image, or then 100% sure that line break will be shown more prominently. But if you shrink the image, shrinking, then what, that line break may go, right. So, there is a lot of issues are there. So, this enlarging this one is not that easy, or reduce. Suppose if you reduce it, then maybe 2 features, correct features you may lose, right. So, while designing the matches, you must ensure that device quality or device performance or device characteristics are taken into account correctly, right. So, this is the simple thing that you have the biometric subject, another subject has come, maybe same subject, they have given their data through sensors and the sensors extracted the features and then through matching engine he gives you some score. So, if you know these two biometric samples in front of you, then obviously you will be able to design or you have to state the two hypotheses. These are the two possible hypotheses, one is null hypothesis, another alternative hypothesis. In the case of null hypothesis, you will be telling that two samples are matched. And in case of alternative hypothesis, you will be telling that two samples have not matched. Now, this definition of hypothesis is again dependent on the applications. For what purpose when are you going to tell that two are matched? In my classroom, out of suppose I introduce a fingerprint scanner to take your attendance, or as you know that in front of you, you have one fingerprint scanner, right, you are using. Is there anybody who faced the problem that not enrolled or not accepted? Did you try? Are you giving your attendance? No. You are doing, right? This attendance, the kiosk is there, card, and then you give the fingerprint? No, just enter the card only. See what happens that in my attendance system, classroom attendance system, suppose I get the 80 minutia points, and out of 80 minutia points, even if I find that 5 of them are matched, I will tell that okay, attended, because it is not a great thing that somebody else will not, I am sure somebody else will not come to my class, provided he does not gain something from me, or either there are people they come to the class to earn 5% mark as you are attending, right. There are people, very few people will be attending any function, even if it is not of his interest, right. There must be something. I will attend a seminar if it is of my field. This is simple thing, right. So, if you tell no, you have to attend, maybe you will be attending, but you will be sleeping, nothing will come out of it. So, this in my hypothesis, null hypothesis is dependent on the application, what purpose I am designing. Suppose I am thinking that no, this attendance is very important, then obviously I will put that out of 80 minutia points, 70 minutia points must be matched. So, this will be a little tighter side, right. Now, these applications again is dependent on the different types of error. As I told you that if 5 out of 80, if it is matched, I will tell yes, he attended, right. Another case is that no, 70 out of 80 if it matched, then only I will tell he attended. So, this error range will be different, right. But my matching engine must return one of them. Either you have to tell do not match or you have to tell that match. So, one of the hypotheses is true. Either you have to tell H1 is true or H0 is true, right. You cannot tell, we do not know which one is true. So, you get the two term obviously, one is the correct match, another one term you will be correct not match. Correct match means that you have got the two biometric samples and they are correctly telling you that yes, these two samples are from the same persons. And correct not match means that you got the two samples from the two different identities or two different subjects, and your system must be able to tell correctly, right, that yes, they are two from the two subjects, right. And the ideal situation is that under every circumstance, for genuine case, it should give you always the correct match, and for all the imposter case, it should give always correct not match. That is the ideal scenario. Am I right? But this is not the case. and as a result there are two terms are coming, type 1 and type 2 error. This is true for any pattern recognition problem, and here also it is biometrics also based on the pattern recognition. So, these two errors will be there. One term is false match. Given the two biometrics characteristics, you will be telling yes, they are matched, but in reality that should not have happened. They are two, these characteristics have been obtained from the two different subjects. Now, the frequency of that type of error is known as false match rate or false acceptance rate or type 1 error, right. In our case, most of the places you will find that we are using FAR, false acceptance rate. So, false acceptance is the ratio of number of times it failed or number of times it falsely matched, falsely accepted divided by total number of times you have tested. Suppose you have tested n times, out of n times k times falsely matched, then that will become the ratio, right, k by n into 100, that will give you the percentage. And false non-match is that it decides the two biometrics are not from the same subjects, but in reality they are from the same subjects, right. You are telling no, they are two different subjects, but in reality they are from the same subject. And the total frequency of occurrence such type of error is known as false not match rate or false rejection rate and type 2 error. So, type 1 type of error gives you the indication that your H0 is true wrongly. Type 1 error is responsible for wrong acceptance of H0, and similarly type 2 error is responsible for the wrong acceptance of H1 or rejection of H0. So, S is the score, matching score between the two biometrics template. This word also you will be finding that very frequently we will be using the template. Template is nothing but the feature vector. That means what? The feature vector is nothing but the vector containing the features obtained from the biometrics characteristics, right. So, remember that feature vector is also is not of same size. For example, that today you have come and you have given the data, you may give the data which contains n minutia points. Tomorrow you come again, and if I take your data, it did not be that n minutia points, it may be m minutia points. An intersection between n and m may be k. What it means? That today whatever minutia points you have obtained from a fingerprints and what data you obtained yesterday, these two are not giving the same minutia points, right. Maybe some of them are yesterday they could not that your device could not get, today it got it, and another one is that today you did not get, but yesterday image could provide that minutia points, right. Also, in both the cases there is a possibility of false minutia points. What it means? That as I told you that there is a break, this break will give you the false minutia points, right. So, there are several issues. One is the false minutia points, true minutia points. In the case of true false minutia points can occur in both the place, both the times, and in the case of true minutia point also it may so happen today I have got some true minutia points, but yesterday did not get and again today I did not get, yesterday I got it. That may be a possible case. So, based on that, S is the similarity measurement between the two samples, and when similarity measure, the word is similarity is important here. then when S is greater than some threshold value or greater than or equals to some threshold value, you tell your null hypothesis is true. Null hypothesis is that two samples are matched. Otherwise, you will be telling that your alternative hypothesis is true, that means that two samples do not match. Now, sometimes taking such a decision becomes very difficult. It is very difficult, because based on the matching score, you are taking that match or do not match. Now, there is no scope for you to tell closely match. This is very, say I tell 50 out of 80, if it is there, then you tell match. Now, suppose I got 49. 49 out of 80, can you tell matched or not matched? You will be telling, because you have to tell that this is a threshold value. If it is at least 50 out of 80 matched, then only you tell accept. So, 49 out of 80, it is less than that, you will be telling him that throw out, telling that no, it is not matched. But in reality, you will be telling closely matched, right? Or sometimes it is a borderline case. You tell user, I do not know, it is a borderline case. But that type of decision is not allowed, and this is known as decision making without any exception handling. And this type of reliability of your score is dependent on this type of parameters, that whatever score you have obtained, S value you obtained, they are dependent on these three parameters. These parameters are all because of variation in data acquisition. As I told you that today is bad day for me, so my biometric data is bad, but it may so happen. So, variation is in data acquisition, variation is in sensor, variation in data representations, and these variabilities are very high compared to variability in authentication method like password or key and so on. Because in the case of password, you can make some mistake in entering the data, nothing more than that, right. But here it is not with you, it is not with you. You have come, you are a genuine person, you have given your data, but because of this type of parameters, you are facing problem. So, the variation is very high compared to the other one. Now, I have come the day to give you the data twice. Even I get the data within an interval of 5 minutes. You observe that ideal environment that my matching score should have been 1. If it is normalized lying between 0 and 1, I will tell the score is 1, because same person within 5 minutes you have given the data that my features should be such that they are always matched, all features should be matched, and I should get my matching score 1. But it is not the case. It is only when you will get the 1, when the same photograph you have used, same image you have used twice for matching. However, it can be told that yes, that matching score will be near 1 or is very large, as time distance between the two images is small. So, generally for the genuine case, matching score will be, for the similarity case, the matching score will be large or nearer to 1 and so on, but it will not be 1. Suppose you get 1, but with 100% match, you can immediately draw a conclusion that the second image is the copy of the first image, right. Similarly, that if the two samples are acquired from the two different persons, then obviously the matching score should be 0. The two minutia points of the two samples, if I try to match, it should not match at any case. But again, this is not true. There will be out of 80, some minutia points you will find they are matched, but the number is very less compared to the Manisha points of the same subjects, right. So, it is not 0, but it is low, Now, you tell that my null hypothesis is accepted. What when you are telling that if my score is greater than t, otherwise t is the threshold, otherwise you tell no, my H1 is accepted. What it means in case of false match, an imposter has come with some idea and he has given to you, and accidentally the matching score has gone up. Say in the case of signature, a forger makes several trials, after that he comes and he gives the signature of one person, and there is a possibility the matching score between the two signature characteristics is very high. So, imposter is lucky enough to make it through, to tell you that H0 is accepted. Now, H1 is accepted. What it happens in that case, S is not a greater than T, right, and as a result you will be accepting H1, not H0. Here it is happening like this, that my day is not good day and I have come from the field and I am immediately giving you the data, and accidentally that all the biometric features I am not able to extract from your characteristics. So, you will not be able to draw any conclusion, and because S is very small, and so you will be drawing that no, it is not matched. So, this diagram tells you whatever I covered till now. Based on this, there are two graphs. One is the graph for genuine persons, another is graph for imposters. Now, what happens that if I have a sample size of n or n people's data I have taken, their feature vectors I obtained, and if I put the matching score, what will happen? Since they are genuine persons, their values will be, matching score will be in higher side. See here I have taken, say it is minus infinity to plus infinity, say. So, the matching score will be it will be higher, as I told in the beginning, that or in few slides back, that if the features from the same subject, features of the same subjects are matched, the score will be high, right. So, the score will be, this is the scores, this is the frequency, right. So, there will be people, more number of people will have the score, this score is very high, right. So, as you know, for large value of n number of population, it obeys the normal distributions. So, this will obey similar type of thing. So, very few people will have this type of score, but very few people will have the score of infinity outside. But at the same time, because as I told you that two samples will not give you value 1 or infinity, but most of them will be here, right. Similarly, is the case with the imposters. Now, in the case of imposter, the scores will be much smaller compared to the case with genuine, right. And you will find that this peak will be much closer to this side, because most of the cases it will fail, but very few of them will have the high score, right. So, this region, so this will be a graph for imposters, this will be graph for the genuine, and there will be some overlap because of pattern matching, as I told you. So, if I consider that this is the threshold, so all the scores or all the persons whose matching score is greater than T, you will be accepting. That means, this people, even though they are imposter, they will be accepted. And that is known as false match. So, the total number of cases out of these occurrences will be your false acceptance rate. And these people, because of this threshold, they will not be accepted wrongly. This is known as false non-match. Okay? So, if it is the case, can I define my false match rate is 1 minus infinity to t probability density function of, that is minus infinity to t, right, 1 minus, this is the 1, this is the 1 minus infinity to t, this graph. Right? This is 1 minus this false match rate. Yes. False match rate is what? This is false match rate, right? That means 1 minus, this is what? 1 minus this part. So, this is your false match rate. And the false non-match rate is minus this part, minus infinity to this of this curve. Okay. So, again if you see the distribution, you observe that there will be overlap. You will not get a situation where both FMR and FNMR they are 0. You will not get, because there will be an overlap, because this is a pattern recognition problem. So, only thing is that you have to select the T. Based on that, you have to tell whether false match rate or what should be my false match rate or what should be my false non-match rate. The T is important based on the application, because in some application I may not like to allow any suspected people, right. So, what I will be doing, that there should not be any false match, right. Now, I want to make it false match 0, I do not care what should be the false non-match, right. Similarly, there are some applications where I want to make false non-match is 0, but I do not care about the false match. So, but you have to decide your T in such a way that this my condition satisfies. What you observe, that these two are inversely related. So, T controls this trade-off relationship between these two. If T is high, because it is a similarity measure, if threshold is high, if T is high, then what happens? This is becoming less, but false non-match is becoming high. But if T is small, T is here, in the case of similarity measure, false non-match is less, but false match rate is high, right. So, you have to decide your FMR and NMR based on your T. Now, there are 3 factors coming in your mind, one is T, another one is false acceptance and another one is false rejection. And these 3 parameters are, if I know one of them, I know other 2. If I know the threshold, I know what is FM and what is FNMR. If I know the false acceptance, I know what is T and what is false rejection. If I know false rejection, I know the other two. So, they are related, right. Now, the cumulative density function also you can define, right, and this if you draw in the diagrammatically, you can see the diagram of these two will be like this. This is a simple diagram. So, given the score densities, we like to know FAR and FRR. I know the score densities, I want to know exactly what is my FAR and FRR, but unfortunately, you cannot do that. You cannot get exact value of FAR and FRR, because you do not have the total test data, right. So, it cannot be computed exactly, but you can give the estimated data based on your test cases, right. Now, this is also very hard to obtain the false match rate, because to obtain the false match rate, you need to know or you need to get some imposters, right. So, you know, if I tell you that can you copy his signature, you will start thinking that is my teacher is telling, because once I do it, I may be in problem, right. Then he has the habit of forging other signature. So, I can give you one example. You know, one day I kept the key of my door inside and then I latched the door accidentally. Obviously, nobody will do it, right, accidentally, because I kept my key and I latched the door. Now, I know where is the key, because you know everybody keeps his key in appropriate in some positions. I know the key, that it was evening, dark. Then I called somebody that can you help me to take out the key. Then I explained that it is there and I need a bamboo where he will put one iron like this and he will bring it, because there is a key ring. It is a simple process. And I told that I have a torchlight also, I will provide everything, just you keep bringing it. Then he saw this position, yes, the key is lying there. I gave him the small bamboo stick type things, iron things and everything. But he suddenly told me, no, I will not do it. I don't know why. Very simple. Today if I do it, then tomorrow you will tell that I have the habit of doing this, that I know how to take out the key from that area and other things. So, at that time, you know, in the campus was not safe. Nowadays I do not know, but at that time campus was not safe. Every alternative there is some theft cases, stealing small items. So, he was afraid of this. So, similarly, if I tell you that can you sign on the check leaf, I will give you my signature and copy it. I want to test whether some bank people can catch you or not. Then also you will think, no, no, I will not do it, because you will think that what is the reaction afterwards, I do not know. So, getting impostor is not that simple. So, as you do not have the impostor, how can you find out the false match rate? See what happens, what we are doing currently is a very wrong method, but we are doing it. We are showing that false match rate is this, because suppose I have the phase database, and I want to find out whether what is the false match rate, what is FAR, right. What I do? I take your photograph and I matched with everybody else, right. And again I take his photograph matched again everybody else. That means one leaving one and I am matching with everybody else. And then how many times it matched, based on that we obtain that. But it does not make sense in reality. How can I take your photograph and match with him? Does not make any sense, but we are doing it to draw the conclusion of FAR. But in reality that is not the correct thing. In reality is that you have come or somebody else has come with your face and whether it has been matched or not. So, that should be the thing, that I have put some mask on my face which is similar to your face, and whether I have been caught or not, that will be your false match rate, right. But the people, there is a strong group of people who does the or who works to force the signature, that is possible. If I try several times, I am sure I will be able to copy your signature, right, copy your walking style, copy your voice. This may be possible, but it is not possible to copy my face, right. You cannot copy my face characteristics, right. So, the people are working on signature forging, and it is a very good field of work also, right. It is a good field of research, that by seeing your signature, can I copy your signature? It is not that easy also, but it is a work is going on that. And these error rates for given t can only be estimated properly if these represent the target population characteristics. That means, if I have the database and if I understand carefully that behavior of each characteristic in the database, right, and then you design your system. What it means, that suppose I have a population of size n which is not available with me, but I have a training set of size small n. These small n size people, they are covering the whole population characteristics, that they are from different background, different age groups, different genders, and so all characteristics are inbuilt in this training set, then possibly these error rates that you can obtain properly. Now, since we are using one leave out method while computing false match rate, one leave out means, suppose I have a data n is 1000, small n is 1000. For genuine match, what I do? I take one person and I am checking the data with this person, the designated person, that a person with identity 1 is compared with the database of the person with identity 1 only, right. Second, and database second, third with database third. So, genuine match you can measure, and this is 100 such cases, 1000 such cases, because I have 1000 database size. Now, in the case of imposter, one leave out, because I will be leaving out myself. So, 999 I will be compared with remaining 999 people, am I right? And there are 1000 such people. So, 1000 into 999 size, that means 1000 to the power 2. So, in the case of estimating false acceptance rate for a database size of 1000, I have the result on 1000 square approximately. There is a 999 into 1000. Whereas, in the case of genuine, this is genuine, but it is false non-match rate, I have the size is only 10,000 or 1000, because my database size is 1000. So, the genuine case, I am for the genuine, that false non-match rate is estimated based on 1000 data, and false match has been estimated on 1000 square data, right. So, that is the thing we want to write here, the confidence on false non-match rate, because size is very less, is less compared to the false confidence on false match rate, because false match rate size is 1000 square, okay, in our database. So, you observe that false non-match cannot be 0, because if you make it 0, then false match rate also will be very high. There it will be near 0, you can tell, but it is not 0. If it is not 0, then I am facing two more problems. One is reputation, another one is accountability. That means, I will be denying some genuine person to use the system, because non-match rate is not 0. That means, there will be some people, genuine people, for them I will tell no, it is not matched, and he will be unhappy. So, genuine person will not be allowed to use the system, right. So, in the case of knowledge or possessions, right, this can be shared. So, a person can deny that I have not used it, or right, because I have the key or I have the password and I have done something wrong. Later on you can tell no, no, I have not used, maybe somebody has taken my password, or my password has been stolen. This happens while you see that in some activity, whenever we catch some students in the computer centers activity, so, sir, I do not know who has taken my password, right, and all passwords are freely available. So, he can always tell that yes, I have not done this work, he can always deny, but this is not the case with the biometrics. But again, you cannot tell that no, there is no error. There may be some error because of pattern recognition, as I told. Because of that, accidentally he has been masked. Now, you have the word false acceptance rate and false rejection rate, or false match rate and false non-match rate, and you have also a T, the threshold value. Right. Now, if I draw, I can have the two graphs. Here it can be false acceptance rate or false rejection rate, and here I have T, threshold. So, what you have? I am drawing a graph now, threshold you have, and you have false acceptance rate and false rejection rate. Now, in the case of false acceptance rate, it is the graph I am talking about with respect to the similarity match. Now, if T is small, what will happen? False acceptance rate will be high, and if T is large, so graph will be like this, right. And similarly, the other one will be like this, right. So, this is known as FAR versus FRR graph. Now, again this FAR and FRR graph also can be represented in different way, which is known as receiver operating characteristic graph or curve. So, this ROC gives you that at different threshold value, as I told you that if I know the threshold value, I know what is FAR and what is FRR, right. So, I can have similar type of graph that when threshold is at threshold some minus infinity, you will be getting FRR is this, FRR is this, and then this point, what is the threshold at any some particular threshold value, FRR is this and FRR is this. You can get all the term, yes or no, this graph will be there. So, this is FAR versus FRR graph. This is known as ROC curve. Now, this ROC curve is false acceptance rate is 1, near 1, it cannot be 1, but this will be 0, near 0. False rejection rate will be 0. and this is 1 and this is 1, but it is near 0 for FAR. FAR 0, but FRR is 1. And the t is here minus infinity and here t is plus infinity. And this for a particular t. For a particular t, FAR is this, FAR is this, and FRR is this. So, suppose I want small false acceptance rate or less acceptance rate, but so less acceptance, say x1, then you know what is my false rejection rate and what is my threshold. You can easily obtain. See the graph, I started with the 3 parameters T, FAR and FRR. Now you observe that one is redundant, T is not required. So what you have done, the graph you have obtained FAR and FRR irrespective of my T. T I do not need, T is your thing, the designer has to decide what should be my T, so that I get this FAR, and obviously I want one near 0 and corresponding value of other one. So, this selection of T, FAR or FRR, this is termed as operating point. This point is used to decide the what should be my system, what is my performance of my system, everything is dependent on this operating point. I think these are the things I already covered. Now, these ROC curves, one ROC curve I have shown, right, and this is not only one type way you can represent, you can have several ways this graph, because FAR is what? False acceptance, right. That means what? There are people, some imposter, they have entered into your system, and one leave out method, it is of the order of square. Suppose I have the database of 10,000, one leave out, that number of persons will be here is 10,000 square and this side is on the 10,000, right. So, what do we do? Sometimes the log graph we introduce. So, right, log graph can be in with respect to FAR, maybe with respect to FRR, maybe in both the sides, depending upon the database size. So, the another graph which is known as correct detection error trade-off graph, which is known as DET. Here I have correct match rate. Correct match rate means 1 minus false non-match rate, right. False non-match, 1 minus false match rate, false non-match rate will give you the correct match rate against false match rate. If I draw this graph, that graph is known as DET. So, here instead of telling that false match rate, we use the term false alarm rate. Now, obviously, the detection error rate or the error trade-off will be lying between 1 and 0. This will be 1 when false alarm rate is 1, right. Then the graph will look like. Now, if I give you matching score, if I give you say 10 cross 10 matching score table, can you draw FAR versus FRR for some suitable threshold? Obviously, you have to decide what should be my threshold. Can you draw ROC curve? Can you draw DET curve? Can you think about it? And if you cannot, then let me know. That means in that case I have to explain a little further, and if it will know, sir, it is possible, then I will not. What I have? I have a table which gives you the matching score value. Matching score means obviously you will be telling, sir, is it a similarity match or dissimilarity match? Suppose it is similarity match, then it is lying between 0 and 1, that is also given. Now, what I am telling you that I want ROC curve, right. So, for different threshold value, you have to first find out what is your false acceptance rate and false rejection rate. You can find out. You have a table, and based on that you decide what should be the threshold value, different threshold value you take, right. First you take threshold value 0, then you take 0.1, then you take 0.2, 0.3, 0.4, 0.5, like that you can take, or you could have taken 0.1, 0.11, 0.12, 0.13, like that also you can take, whatever threshold you want to decide. Or if you see that by the table you see that all the points are lying between 0.4 and 0.5, then why to select the other things? You select 0.4, 0.41, 0.42, 0.43, 0.5, all those 10 intervals also you can take, whatever threshold you decide. For that each of them you can obtain the FAR and FRR. Then you can draw the graph FAR versus FRR graph and FRR graph. Then you can obtain ROC, and finally you can obtain also DET, right. It is not difficult. Is it difficult? Now, if I tell you, the difficult will be coming little for when I tell you that can I draw this, if I give you the two matching score diagram or table, they are of different, they are not normalized, means one table has the matching score lying between 0 and 1, other one is maybe -5 to -7, +7 and so on. So, you have to normalize them. Problem will be a little difficult for that if I tell that one is similarity based on similarity score, another one is dissimilarity score. So, you have to make it after normalization 1 minus that you have to take to make it same platform, similarity platform or dissimilarity platform.